As you begin to explore cloud infrastructure options in Azure, you'll often come across two popular terms: containers and virtual machines. Both help you run applications in isolated environments, but they do so in very different ways. Let's break it down so you can choose the right tool for your needs. You might already know that hardware virtualization allows you to run multiple operating systems on a single physical machine. This is the foundation of virtual machines. Each VM includes its own operating system and runs independently, as if it were a separate computer. But containers take this a step further. Instead of virtualizing the hardware, containers virtualize the operating system itself. This makes them lighter, faster, and perfect for scenarios where you need agility and high density. Let's look at how containers and VMs compare across a few critical dimensions. When you use containers, you get lightweight isolation from the host and other containers, which makes them fast and efficient. However, keep in mind that this isolation isn't as strong as what a virtual machine offers. With a VM, you benefit from full separation. Each VM operates in its own environment with its own OS, which is crucial when security boundaries are a top priority. Containers let you run just the user mode portion of the operating system, sharing the host OS kernel. This means you are only using what your app needs, saving system resources. In contrast, when you run a VM, you are launching an entire operating system, including the kernel, which requires more CPU, memory, and storage. Deploying containers is straightforward. You can use Docker from the command line, or go for orchestration tools like Azure Kubernetes Service when you are managing many containers. With VMs, you typically use tools like Hyper-V Manager, PowerShell, or the Azure Portal, giving you full control over each virtualized instance of an OS. For storage, containers give you flexible options. You can use Azure Disk for local storage or Azure Files when you need shared access across nodes. On the other hand, VMs rely on virtual hard disks for local storage and can also use semi-file shares for multi-server access. If a container hosting node goes down, the orchestrator, like AKS, can quickly recreate your container on another node with minimal disruption. VMs handle failure differently. The VM can fail over to another host in the cluster, but the operating system needs time to reboot, which can cause delays. You should use containers when speed, flexibility, and efficiency are critical to your success. If you are looking to develop, test, and deploy applications faster, containers give you the edge. They're ideal when you want lightweight, scalable workloads that can run side by side without consuming unnecessary resources. You also benefit from higher workload density and better resource utilization, which is especially useful in dynamic environments. If you are building microservices or cloud-native apps, containers make it easier to break down your application into manageable, independently deployable components. Think of them as small, fast-moving, and highly adaptable units that are perfect for both development pipelines and production environments powered by Azure Kubernetes Service. On the other hand, you should turn to Azure Virtual Machines when your application demands strong security boundaries, depends on a full operating system, or includes legacy components that aren't compatible with containerization. VMs give you the full power and isolation of a complete OS, which is exactly what you need when running complex configurations or heavy-duty workloads. If your apps weren't built with containers in mind, or if you are managing sensitive environments that require deeper separation, virtual machines remain a reliable and robust solution. So, what's your key takeaway? You're not limited to choosing one over the other. In fact, many real world architectures use both VMs and containers side by side. Use containers when you need speed and scale. Use VMs when you need control and isolation. Mastering when and how to use each will make you a more effective Azure administrator.